In this video, we are going to take a further look at quadratic functions. We're going to start evaluating them. You've already found x-intercepts. Now we're going to start evaluating specific numbers along the way. Now please keep in mind, I'm showing you all three of these initially because I want you to see the difference between letter B and letter C. Letter B says find g of -4, which means -4 is going to go in place of x. And in part C, I want you to find x when g of x equals -4. So that g of x value, that quote-unquote y value, is now -4. So what I want you to do is I want you to go through all three of these parts. You already know how to find x-intercepts. Think about what an x-intercept is. What do you do with that? Then go through, after you've done that, do B and C. I am going to start going on how to go through x-intercepts, and then lastly I'll take a look at B and C. So pause this for a moment. See if you can do this without me even walking you through any of it. So an x-intercept occurs when y is 0, or in this case, g of x is 0. So I'm going to put 0 in there. 0 equals 2x squared minus 5x minus 11. So now I have to go through and solve this. Since it's 0 equals, it is an equation, I can solve this one of two ways. If you remember back, we can either do factoring, or I can do the quadratic formula. To see if I can factor this, I can do the discriminant. B squared minus 4 times A times C, which ends up being 113. 113 is not a perfect square. Therefore, I'm not going to factor this. I'm strictly going to do the quadratic formula, which means I'm going to get irrational values. If I just wanted to find what the values were, I would leave them in exact simplified radical form. In this case, what we're going to be doing is we're going to be looking at what does this look like graphically, so I'm going to get some approximations. Keep in mind that when I'm solving pieces of information, I keep them exact unless I'm going to go graphically with these. So I have to go through and do the quadratic formula. So there's my exact value. I approximate this. I get x equals -1.408, going 3 decimal places if you need to round, and 3.908. So what I just calculated were my x-intercepts. So if I were to graph this, it is going to be crossing my graph at -1.4. And at 3.9. So there are my two x-intercepts. Okay, so that's the initial part. What is this calculating? How do I find it? So you've done that before. Now we're going to move forward and we're going to look at evaluating these situations. Finding g of -4, that's as if I'm telling you what my x value is -4 and you're finding your y value. In part C, I'm giving you that y value, and you have to find your x value. So keep in mind the differences between these two. So in the first one, -4 just gets substituted in for x, and I get 41. So when I put -4 in for x, I get 41 out. So I could add to that graph. So -4, +41, say would be up here. Keeping in mind I can do a symmetric point, I'd have to extend the graph here on the right as well. And I could find that symmetric piece as well. So let's see here. So there's my axis of symmetry. So rough sketch, it'd be up here. So now I have a graph that opens upward. I know my vertex is somewhere along that dotted line. So next what I have to look at is what does x equal when g of x is -4. So now I'm looking at my y value of being -4. So looking at this graphically, I have a y value of -4. So this value up here was 41. So we'll say this value here is -4. So what I'm trying to figure out is where along there do I have two coordinate points? Well, according to the way this looks, maybe it's here and here. Maybe those are the two values where it's at -4. That's the part that I have to now figure out. Okay, so where about does it cross there? Does it ever reach there? So that's my next process I have to work on. So now what I have to do is I have to plug -4 in for my y value, or in this case my g of x. So -4 equals 2x squared minus 5x minus 11. Okay, got to solve for x. Great. I have an x squared and I have an x. How do I do this? How do I solve a quadratic when there is an x squared and an x value? Just like normal. Factor or the quadratic formula. But before you do that, it has to be set equal to 0. So the very first step I have to do is move that negative 4 over. So I'm going to add 4 to both sides. So 0 equals 2x squared minus 5x minus 7. I'm not going to go directly to the quadratic formula if I don't have to. Factoring it is quite a bit easier. So b squared minus 4ac, so 25 minus 4 times 2 times negative 7. I get 81, perfect square, therefore I factor it. Okay, so product is negative 14, sum is negative 5. The two numbers that work are negative 7, positive 2. Can't shortcut this. My leading coefficient is not 1, so I have to go through and split the middle term or do the box method. So 2x squared minus 7x plus 2x minus 7. This, of course, equals 0. So go through, group, make sure there's a plus sign between there. Factor out an x, then I'm left with 2x minus 7. Plus, factoring out technically a 1, and I'm left with 2x minus 7. It's the same thing, so I add my coefficients. So x plus 1, 2x minus 7. Set each of those equal to 0. Therefore, x equals negative 1 and positive 7/2. So what I just did is I found out what x values, there's 2 of them, give me a y value of negative 4. So negative 1 spits out a negative 4, and 3.5, 7/2, however you want to say it, spits out a negative 4. So going back to our graph, at negative 1, it's down at negative 4. Ah, that was a pretty good guess. And at 3.5, there's my other one. Those are down at negative 4. And then maybe I have a point here, and here, and here, and here, and then here's my vertex. Something along those lines. That's not very U-shaped. But it's going to be something along that process. But what we're looking at is we can evaluate all sorts of values. I can give you an x, you have to find the y. I can give you a y, and you have to find the x. Both directions here. Part of the reason I'm taking a look at this is I'm sometimes going to ask, can y be negative 20? Does my vertex ever get down to negative 20? And without physically having to graph this, you can do a couple of really quick processes to determine that. And so that's what the last example is going to do. Here's my equation. Y equals 5x squared minus 8x plus 6. Does y ever equal 3, or does y ever equal negative 4? It may cross both of them. It may cross none of them. But what I'm trying to figure out is, does it ever cross that horizontal line without trying to go through too much work? So what I'm going to do is I'm going to put 3 in and see what happens. So 3 equals 5x squared minus 8x plus 6. So I'm checking to see, does 3 ever work? So to see if it works, I plug it in. And then what I have to do is I have to evaluate this. What kind of value can I get out for x? Or can I get a value out for x? But just like normal, I have to solve this. It's a quadratic with an x squared and an x. Has to equal 0. Now, instead of going through and doing the quadratic formula, factoring it, read the question. This is important. What does it say? Does y equal 3? Not what's the x value when y equals 3, just does it equal 3? So what I was doing before is I was doing the discriminant to see if it was a perfect square, because if it was a perfect square, then I could factor it. Well, now instead of doing that, I just need to see, can I get a solution out? So when I go through and I do b squared minus 4ac, and I check that discriminant, 64 minus 4 times 5 times 3, I get 4. So does y ever equal 3? Yeah, absolutely. And more specifically, there will be 2 real rational values. 2 real rational values for that. Because it's a perfect square, I can factor it. That gives me the rational ones. Real because it's positive. 2 because it's not 0. I discriminate 0. When I do the plus and minus 0, I get the same value, so there's a double then. It just happens at the same spot, which, as stated earlier, gives you your vertex. Okay, then when I look at negative 4, can y equal negative 4? So plug -4 in. -4 equals 5x squared minus 8x plus 6. 0 equals 5x squared minus 8x plus 10. Again, same thing as before. I'm just trying to figure out whether it can or can't. So I do the discriminant, and I get 64 minus 4 times 5 times 10. Well, if you look at the far right side, that's a pretty big negative number. That's negative 136. No, absolutely cannot. Because if I'm going to do the quadratic formula to try to figure it out, this is the part that's under the radical. The part that's under the radical is negative, which gives me an imaginary number, which means graphically this does not occur. Graphically, this does not occur. So, will this graph ever cross y equals -4? No. If I were to solve the problem, there'd be two imaginary solutions, but graphically it can never equal -4. So what I asked you to look at is, could it ever cross 3? Y equals 3. Yes, it did. It crosses here twice. So I'm just going to randomly say, okay, it crosses it here and here. Then I asked as well -4. Here's -4, for instance. It said it did not cross there. Therefore, my vertex falls somewhere within this range, but does not ever reach that value. So maybe it sits here instead. And then it opens up. Now I could figure out a little bit more specifically what's happening. I could figure out, do I have x-intercepts? Plug 0 in and calculate it that way. But this is the process that we're working at. Can it reach different values? It gives you a little bit of a better description of where does this graph fall without having to do all of the work along the way.